these questions about matching graphs with functions, basically we're going to try to put together clues about end behaviors and see if we can't figure, and numbers of turns, I guess, and see if we can't figure out which ones are possible graphs for G and H. I do want to point out, it's tempting to maybe bust out your graphing calculator and graph these and just pick one, but I'll say this word possible kind of makes it the case that they could make none of the graphs actually match, but it could be the one based off what the degree and coefficient should be doing. So let me start with H. It's easier to talk about because it's already in standard form, and I can see that the lead coefficient is negative, which tells me that the right behavior is going to definitely be going down, and then I see the degree is even, so the left behavior is going to be the same, and the same of down is down. So now I'm going to look for a graph that's down on both sides, and it looks like I can narrow it down to these two, but which one's the right one, you know? So now I got to think a little bit more. Well, something else I noticed about this graph is that if I were to plug in 0 for x, y would also equal 0. So this graph should contain, or this function contains a graph. The graph of this function contains the point 0, 0. This graph does not go through 0, 0, but this one does. So I would definitely say that h of x could possibly be d. So I'm putting a little d over there. And now for blue, this guy, let me write this down here. 2 times x plus 1 times x squared minus 9. We've got a couple things going on here, but I would say for starters, I want to know what the lead coefficient and degree are going to be. So I can just take just these first terms, and if you multiply these first terms together, you're going to get what the lead coefficient would be if you were to write this in standard form. So 2 times x squared is 2x cubed. So what does that tell me? Lead coefficient is positive, so the right behavior is going to be up. The degree is odd, so left behavior is going to be now down. So we can figure out this up on the one side and down on the other. So you're out, it's down to these two. These are up on one side and down, up on the right side, down the left. The other thing is they wrote this in nice factored form. I can break this down even a little bit further. This x squared minus 9 kind of sends a little bell off in my head. It's 2, it's x plus 1, and then it's x plus 3x minus 3. So I can look at this and know that the zeros of this function, or the x values that make y equal 0, are negative 1, negative 3, and positive 3. So since those values will make this function equal 0, they'd make the y value equal 0. So I'm looking for a graph that has x-intercepts at negative 1, negative 3, and positive 3. So between these two choices, which one has graphs, has x-intercepts at negative 1, positive 3, and negative 3? It's this guy, right here. So this is what this guy is going to be g of x, and that's going to correspond to graph f. So we're kind of pulling together all the things we've learned about over the last couple sections, and some combination of them is going to help you use process of elimination to get this all figured out. So I'm sure you puzzle it out, think it through, treat it like a puzzle, and be patient with yourself as always. Good luck.